Bismillah Rahman Rahim. Today our lecture is very important because today we will discuss on the career path, especially in the area of data science, because these days we have lots of queries regarding looking for the future directions in terms of artificial intelligence, data science, data engineering, data analytics, and big data. So a lot of students have queries and they are thinking in that particular direction and also want to develop their own skills in that particular area. So it is very important for us to understand that how you can proceed in your career dimensions, how you can go vertically upwards, how you can have some activities which you might have at the horizontal level, which skills which are important and relevant while you want to pursue your career in data science, data analytics, or databases. So therefore I've started this series, and for the first time I am discussing here data science as career advancements and prospects for youth, because students have lots of questions in their mind that is their degree relevant if you want to go for a pursue for data science field. A lot of students who are there in mathematics and statistics and business analytics and related areas where they want to have their career in data sciences. Of course, the reason is that nowadays there is a career growth in this particular aspect, and the surveys and a lot of you can say the material suggest us that there will be many propositions for jobs, not only in the present scenario but also in future. If you look for data in US, that also says the same thing. Similarly, the hiring in the Middle East region, in Europe as well, and there is a lot of growth in India as well regarding data sciences and relevant fields. So we start our discussion, and we will have a little bit about what data science is, which is very important to understand initially for all of us, especially the young students who want to develop their field. Data science, first of all, is an interdisciplinary academic field. When I say interdisciplinary, it means it involves lots of other fields, many other areas, many other dimensions, and all those obviously are integrated when we talk about data science. That uses statistics, which is, of course, a very important part of it. Not only statistics but also mathematics, which is very important. Later on we'll see why mathematics is important, why statistics is important, because we are looking to develop models as well. We need to understand the analytic behaviors, and we have to transform those things sometimes into mathematical or statistical models. We look for scientific computing methods, this various scientific approaches to deal with the data, whether it can be a network science, complex networks, or nowadays people are using advanced statistical techniques, processes, again visualization, which is a very important aspect when we talk about data science, because in all the domains people look for good visualization tools as well, so they can see how the growth is, they can see the of course the trends, the curves, and various kinds of visualization tools are also integrated into such systems where we can easily understand algorithms and also of course the knowledge of systems. So all these interdisciplinary academic fields are important while we talk about data science. But please do not get you means sometimes when we see a lot of fields, we believe that how we can do it. I think that if you have a combination of few, you can do it. So data science means that you must have a good basic understanding of the various subjects, and obviously you can do it. As far as just using tools, yes, we can use tools. For using tools or application purposes, I don't think so that we need a very in-depth knowledge of various subjects. So some of the tools can easily be used even if you have a basic knowledge of statistics, mathematics, computing, visualization. Why these days there is more focus on data science? Why there are more jobs which have been created over a period of time? And we have also observed that various surveys have been conducted, and according to Forbes, data science analytics is one of the fastest growing jobs of 2024. It has a projected growth rate of 26% from 2021 to 2031. It means the next 5-6 years the growth rate will be 26%, and some of the reports say that even it is more than 30%. So it means we need people who have a good understanding of analytics, those people who have a good understanding of using various such tools. And according to a report by Analytics India magazine, the analytics industry in India reached more than $3 billion in size in 2019, and is expected to double by 2025. Machine learning and artificial intelligence will come to dominate much of the further development within tech industry, because this is the order of the day. We see that how AI is being integrated into all domains, and how quickly we have seen this transformation. The field of data science is a key to that advancement. So how we can unaware of that field? So it is very important for us to have a good understanding of data science. There is one saying that is, the data is the fire of the 21st century, and analytics is the gasoline. So we have potentially a lot of data. Data have been generated, in all domains of life. We are in the online business. There are transactions 24/7 transactions in banking, in finance. You see, there are 24/7 transactions which are going on. So everywhere you can see that there is a big data bombardment, and we should know how to utilize that data. That is the most important thing in this field. How we can extract the meaningful content out of data, how we can find out the hidden patterns, hidden behaviors lie within that data, how we can forecast, so that if we have a better forecasting, we will be able to make better decisions. So therefore, the need of data, the data organization, data repositories, data warehousing, analytics, this is very, very important for the industries. So here you can see that there are various domains. When we are students, sometimes we are puzzled. We have no idea what to do. Sir, I want to continue my career in data science. What to do? Whether I can go with the artificial intelligence. We have programs in artificial intelligence as well. You can even go for a 4-year degree, a bachelor degree in artificial intelligence. Yes, it is possible. Computer science is considered to be a mother domain. That is one of the advantage of the computer science is that since it is a mother domain, because it covers almost all the aspects, all the computing aspects, including AI as well. So the one thing which we can do is that we can opt for a computer science in our bachelor's program, and later on we can go for specialization in any of the domain. So there are lots of related concepts with the data science itself. Degrees have been offered in this field as well, bachelor's degrees in data science. Human computer interaction, software engineering, network science, intelligent computing, deep learning, data engineering, machine learning, lots of concepts. And there is, of course, the overlapping in some of the areas. And and obviously whenever we have such curriculums where we have some sort of overlapping, it is very difficult that how you can take machine learning out of artificial intelligence, how you can take machine learning or deep learning out of data science, because whenever you are looking for the data science, you look for ML based approaches, and whenever you are look for ML based approaches, obviously you need a good understanding of the logical systems as well, logical agents as well, and this is connected to your AI. So all these fields have some things in common, but obviously have you can say their own dimension as well. But now it is up to us to decide which domain suits well for us to pursue our career in any of the disciplines. Some of the disciplines have been offered in various universities wherever you are living, and you can also opt for domains which are not there in the related in universities nearby. You can have the discipline somewhere else. So these are the various disciplines, and there are other as well which you need to be considered. When you talk about a data scientist or a data science or a person who want to pursue in the data science field, in this diagram you can easily see that the math and stat and computing, of course, that is one aspect which should be a part of a data science scientist or a person who pursue field in data science. So he or she has to be good in math, stats and computing. One aspect is computer science itself, of course, and the third important thing, which is very important for a data scientist, and that is domain knowledge, the concept about the various domains, how we can analyze problems, how we can have data, how we can relate that different data for to solve a problem in a particular domain, because a data scientist might work in healthcare domain where the data is of different kind. Maybe you are supporting the physicians for a particular disease, or you are looking forward to determine some sort of patterns in the data in the lab data you have for maybe millions of specimen which have been collected. So you want to look forward to see, or you want to have some sort of a gene data with yourself and you look for a certain analysis. So domain knowledge is very important. It means that you must have a good understanding of a domain. For example, if you're working in finance and banking, how different problems are coming over there, how we can protect ourselves, how we can detect frauds, how we can find out the white collar crimes, how we can look for a suspicious transactions which have been there in our financial system. So there are millions of transactions daily. How to look for it? For example, if we are looking for call detection system, so there are again millions of calls per hour, and from that data, how you will find out those connections which you think are the suspicious one. So it means that we are talking about various domains, and obviously various domains have various requirements. So the data scientist, whenever we say a data scientist, he or she must have a good understanding of analysis, of understanding requirements, to know how to deal with various domain experts, should know the methods by which that information can be acquired, should be good in communication with those people who need a specific output or a requirement to solve their problem. So it means that the concept of domain knowledge is very important. Another important aspect which is shareable between the domain knowledge and the math and stat skills is called the data analyst. And data analyst, as you can say, can be any person who has that knowledge, how to acquire, how to collect, how to pre-process the data, how to apply various models to the data to find out various, for example, outcomes related to a particular domain. So data analyst, as you can see, is a subfield, but data analyst might lead to a data scientist, you can say, or a data scientist must have the potential to use various tools which are there for solving problems. One more important question which normally student asked is how you can differentiate between a data scientist and a data analyst. I think it is easy, because whenever we talk about data analyst, remember, any person who has that capacity to look into the data, has that capacity to gather, to apply some pre-processing techniques to clean that data, and provide and also apply the basic analysis tools, for example, maybe in advanced Excel, maybe using Google Analytics, or maybe using some Power BI functions to perform certain analysis, comparisons, trends, regressions. So all these things comes under analysis. So data analysts provide insight into the basic business performance, develop analytical system to act as a single source of truth to facilitate ad hoc analysis, because we need outputs, we need various graphs, we need various comparisons, explain the outcome by identifying trends. Obviously we look for trends in a business. I might be interested to know what is the trend of my sale, how that trend varies in various quarters, what type of social groups are there, and how those trends are have been evolved, and how I can compare this with my online business, with my physical showrooms. Creating visualization, that is another part which analysts can do. There are various tools which are available which can give you a very good visualizations and views which are useful for the users to understand and comprehend the system and the outputs. And obviously look for certain key performance indicators which is related to that particular domain. That domain might be a healthcare domain, that domain might be education domain, that domain might be a business planning, agriculture, for example, energy. So these are all various, you can say, the domains where we can apply that thing and tools, and we can have certain analysis. On the right hand side, if you can see the approach for the data scientist, now it is a little bigger approach, because here we look to develop models. We are not there to use only the analytical tools or the models which are already there. But when we say that we are working as a data scientist, then you are also involved in developing models and algorithms to predict the future performance of the business. So you have the data with yourself, look into that data, evolve various models, and see that which model perfectly works for your own problem. And you can also go and change various parameters and see that how those model works, and then you can apply that to your own problem. Generate hypothesis and identify corresponding data needed to solve a problem. So here we look for solutions, and for those solutions we build hypotheses, and then we look and for the particular data which has been required to prove or disprove my hypothesis. Deploy machine learning models, which is very, very important. Machine learning is one of, you can say, a subfield of AI, and artificial intelligence has, since 2022, 2023, AI is everywhere, because this is a now buzzword in the market, because everyone talks about AI. There is a lot of debate that either AI is only be applied after having a proper education, or some people might apply various AI tools and AI techniques, even not having such education. So how they can use that AI? This is a big question mark. So machine learning is one of, you can say, a subfield of AI, deep learning, machine learning. So what is the task? The task is to develop the learning models. How you apply those learning models? Again, that is not the job of analyst. That is the job of the data scientist, to come out with learning models. maybe the convolutional networks is required, maybe other machine learning techniques is required, maybe artificial neural networks are involved, what type of support vector machines might be applied. So how you can think about which machine learning model best suit for my own problem domain. And obviously to execute this, collect data, execute this, apply this for a certain problem in a certain domain. So that is the concept of a data scientist. It means the data scientist is, must be having a proper degree. That would be good, because then data scientists have some aspects of mathematics, statistics, and probability, computer science and computing, and of course the domain knowledge. So some things which are in common: data gathering, data analysis, and data scientists both involved in data gathering, data cleaning. Obviously, cleaning means some of the processes or pre-processing which we apply on the given data to solve or to normalize it. And then we can apply data analysis. Data scientists and analysts both apply analysis, but you see what is the difference between these two. So it means that we need to have some knowledge of various domains. For example, in terms of mathematics, we should have knowledge of these aspects. But these aspects are not just limited, because there are other aspects as well. I have mentioned few just to show you that this is important. You must have the concept of optimization, how to determine the minima and maxima in any given problem, because in most of the problem either we go for minimizing it or maximizing it. So we need to know all those methods which have been used for optimization, whether we are talking about search algorithms, there also we are look for the optimization, or we want to lower cost in terms of performance, we also go for optimization processes. Similarly, linear algebra, we need to know how to transform the given knowledge into linear algebraic equations, and how we can solve those equations to come out with a specific analysis. Dimensionality reduction, of course, that is important. Regression itself is a model. So how we can apply regression to a given data, whether we have that understanding that given data, how to regress it, how to put a plot, how to have that equation there, and we can see that how those values far away from that particular model. Similarly, the matrix, analytical geometry, all these things are important, including the vector analysis. When we talk about statistics, obviously the basic things about statistics are very, very important. You should know about it. How to describe a data, basic statistics description, basic statistics, including random samples. You must have the concept of random sampling, which is very, very important, because we are dealing with the data. You should know how to collect data and how to sort that data, how to take sample from the data. You are going for a study, how you could go for random samples. So there are various sampling techniques, sampling distributions which you might use. Similarly, parameter estimation, hypothesis testing, because most of the time in research we go for a certain hypothesis and we try to prove or disprove our hypothesis. So build your H0, build your H1. So you should know about hypothesis testing concept. ANOVA, which is very important, analysis of variance, which is, you can say, a basic statistics which we need while we are going for our analytics. Reliability engineering, stochastic processes, because we are dealing with in our life with lot of stochastic processes. A student asked me how you can differentiate between a stochastic process or a probabilistic one. So I just answered him that it is easier, because both of them basically deal with the probabilistic system, and real life situations in most of the problem we deal with are probabilistic and or stochastic, because we are looking not for we do not have sometimes exact value, so there is always a probability. So when we talk about stochastic system, here we're talking about the probability, but that probability changes with time. And in the simple probabilistic systems, we do not deal with the time, because when we toss a coin, normally what we say is it is head or tail, so that's it. So whether if I toss that coin in the morning or I toss the coin in the evening, it does not change the probability of the outcome. Similarly, if I throw a dice or a pair of dice in the morning or in the afternoon or in the night, it does not changes. The probability of outcome does not changes. But when we talk about stochastic system, for example, queue handling. So the queue handling maybe varies with time. When you talk about transportation systems, road networks, there the traffic varies with the time. We cannot have a simple probabilistic system. So there we need to look for the stochastic modeling. Computer simulation, you should know how to simulate these things in the computer. Concept of correlations, of course, it is also related with the regression. We must have the concept of variables, dependent variables, independent variables, design of experiments, so on and so forth. So all these things are relevant with statistics. Believe me, these are only few. There are lots of other concepts as well. So if you want to progress, if you want to have a very good understanding of how to build models, how to apply various techniques, you must have a good understanding of statistics. Probability, it is very important aspect, because as I said earlier, in most of the systems we deal with the probability. Therefore we must have the concept of the probability, how how to deal with the probabilistic systems, how to calculate probabilities, what is the concept of a random variable, joint probability distribution, which is a very important concept, and lot of distributions which are important, such as normal distribution, uniform distribution, geometric distribution, binomial distribution, discrete distribution. So we should know that how these distributions have been applied to various problems. In some situations we fit the normal distribution. For a very simple example, if we have an exam and let's suppose I have put all the marks, and let's suppose there is data about 500 to 600 students. So sometimes it is good to fit the normal distribution curve, so that I believe that most of the student will be near the average, and there are some of the students who are on the top, on the right tail, and there are few students maybe who have assumed less marks than the average on the left hand side. So evenly skewed, and most of the observation lies in the center. So therefore the best thing is the normal distribution curve. So it means put that data into the normal distribution curve, and let's see how it behaves. Similarly, we talk about binomial distribution, gamma distribution as well. So you must know which of the distribution is useful in your own problem domain, and you must have the understanding of these distributions. Concept of learning and machine learning, which is very important, which includes the basic concepts of learning, what learning is, what are the learning models, what are the learning techniques, how learning works, what is the input, how that input is transformed into a function, then how a critic is being involved, how the modification is being done, because learning is one of the very important trait of humans, because that capacity is there, inbuilt capacity in humans to learn. Because whenever we do a task and we repeat that task, what we do is generally we try to improve our working. A very simple example is, you start playing chess for the first time, so you didn't have the idea, or for the very first time you know how to move in the on the chessboard. But if you play this continuously and you improve your environment and you improve your opponent, you will learn quickly. Because similarly that thing may be applied in driving skills. When we start driving, obviously we are hesitant, we are scared, and we are not moving very fast, and we have a strong grip, and we are not relaxed. But what happens is that when we start doing this activity again and again, improving our environment, and when we move to the multi-agent environment, what it does, it becomes easier, the task becomes easier for us, because we have that learning trait. The same learning trait can be introduced into the machine, so that machine can work in the same manner as you do. And if this happens, the machine can perform the same task, the task in the same manner as you do, and sometimes it even works better than you. And learning can be converted into supervised learning and unsupervised learning. Sometimes you are dealing with the data which is labeled, and sometimes you are dealing with the data which is unlabeled. So dealing with the labeled data is basically a different task. Dealing with the unlabeled data is a different task. So sometimes we go for the primary source to collect the data, and otherwise, if you are applying machine learning application, there are a lot of secondary resources which are there, from where you can have the free data sets which you might apply for your problem solving. Basic data exploration techniques, you should know about it. Basic ML model, and you should know how to validate your model, because if you have a model, you just can't apply that model. So you have to see that whether there is a model validation or not. Otherwise, obviously, you cannot apply that model, or the results which you achieve from that model obviously is not validated, so it cannot be applied. The concept of underfitting and overfitting, sometimes when we build the model, sometimes it can be underfit or an overfit. So how you can remove this anomaly whenever you have a machine learning model. So lots of applications and tools which are there, and you have the awareness about various tools. For example, Python is something which is very important, and I also suggest to students, whoever look for career in data science, and those having interest in data science, I always suggest them. So either go for Python or R. So both are good, but if you ask me, I prefer Python. And if you go into the Python, you look for the Python basic, list, stat structure, tuples, functions, libraries, and obviously when you work